G'day, it's Rusty from Rusty's Metal Cut Science and Designs, and welcome to part 5 of our How to Build a CNC Plasma Cutting Table. And just to recap the previous videos in the series, in part 1 we talked about what plasma cutting was and what a CNC plasma cutter was in terms of what you needed to move a torch around a tool path. In part 2, we looked at the electronics on the bench, and we actually, with the software from the laptop, we actually made the motors move, and you could see them moving backwards and forwards. And then in part 3, we assembled the X and Y carriages, and we showed you the components we used, the stepper motors and the linear rails and the ball screws to drive the torch around. And then in part 4 I showed you how we made the support table and how it all fitted together and what the finished product looked like in terms of the gantry sitting on the support table ready to go. All we need to do now is to wire it up and get it running. So that's what this video is all about. Now, you've already seen the electronics in part 2, and what we're going to do now is we're going to take all these components, we're going to mount them on this board that I've got here, and this board will actually be the backing for an old PC case. So all these components, so there's the power supplies for the stepper motors, there's a power supply for the MyPlasm CNC controller, and there's also the stepper motor driver units themselves, and they'll all be mounted on this board. And one of the things I'm going to be using is they come with these little terminal connectors that plug into the terminal strip here on the side of the controller. And what I'm going to be using is I'm going to be using these, they call them bootlace ferrules. So these ferrules crimp onto the wire, and I bought a crimp tool as well. And the idea is that it'll make the wiring neater and you won't have wires hanging out of terminal strips. So that's the job in today's video. So I best get on with it, and we're aiming to get this thing up and running by the weekend. So I'll start and mount all these components on the board. I'm not going to show you how I'm going to wire it all up until I've finished, and then once I've wired it all in, I'll go through the wiring and show you how I've done it, but I'm not going to bother showing you how I'm going to put each wire where. Alright, so I'll get on with that now. So what I've done now is I've cut the board to size. I've placed all the components. There's the 2 power supplies for the stepper drivers and the stepper driver motors. This is the power supply for the MyPlasm CNC controller. That's the MyPlasm CNC controller here. These are the 4 stepper drivers. This little power supply is a 24 volt to 12 volt step down power supply for the fans. And as you can see in this case, I'm going to have a fan on this side, on the inside there. On the other side here, I'm going to have a fan. I'm just trying to use what was here in this PC case. And over here, this little buzz bar is for all the screen cables coming back from the field, and they'll be tied into this buzz bar, and then this will go back to the earth point for the power cable coming in. And what I forgot to mention earlier was this panel here, this section here, will actually have a plate on it, and I'm using these, let me show you here, these 5-pin plugs and sockets. They're an aviation style plug. I'm using 5-pin for the stepper motors, and I'm using 4-pin for the proximity switches. And what they'll do is they'll have a plate here, and these will all screw onto the plate. The cables will run to the back of them, and then this is the socket that'll plug into them. So then I can disconnect if I need to disconnect the field wiring. So if I just lift this off very, very carefully, take this PC cover off. So now what I've got to work with is all these components on the board. I can now go ahead and screw them in place, and I can then start wiring. It took me a little while just to sort of work out what was going to fit where. I've got to allow room for wiring harness, and I've got to allow room for cable entry and exits for coming in, and the USB cable comes through here. And I do need to just mount this off the board a little bit, so I'll just put some little spaces under that. So that's where we're at the moment. Now, after cutting the wires to length, and I've just measured them off the, I'll just show you. I'm just running these cables here, the controller. These loomed wires run from the controller, direction and pull, plus and minus, go to each of the stepper motors. I'm just doing Y2 now, and I'll just show you the crimping. Okay, so these wires are cut to length. Use a good wire stripper, and I'm using those bootlace ferrules I showed you yesterday. So I'm taking about 8mm off the end of each of these 4 wires. I'll just take 4mm off each of 8mm off these. So that's I just give the wire a little twist. Now, these bootleg ferrules I talked about, the different colours represent the different size wire that'll fit inside them. So you feed that up inside there and just level, and this crimper tool closes those 4 jaws. Put it in and squeeze it, and that's crimped, it's not coming off. Do the same with all 4 of them. And on the other end, the terminals are a bit small, so what I'm doing is I'm taking 6mm off this end of the sheath and I'm soldering them. So what I've got here, so I've got a little soldering station here, little tiny vise clamped to the desk I'm working at. So I just tap the wire in there, and it's just a matter of tinning these wires because it's a safer connection, I think, into the terminal strip. So there's one. And I've done each of the wires the same way. They've got a crimp on one end and they've got a soldered end on the other end. So just an update as I progress through the wiring. You'll notice the cables here, the 4 colours are actually all twisted together, and actually the pairs are twisted, so the brown and red are a pair, and that's the direction minus and plus signal, and then the yellow and green are the pull plus and minus. So they're twisted together, and then the 4 wires are twisted again. The idea of that is to try and reduce or eliminate any of the electromagnetic interference that you can get from plasma cutter tables and that sort of electrical interference. So twisting them is a recommended thing. So I've used all the same colour wires to represent the Z, the Y, the X, and this is the Y2 because we're running 2 stepper motors on the Y drive. So we've wired up to the stepper motor drivers, not the stepper motors. There's a connection here that comes out from here, and the next thing to do is run cables, or there's voltage from the power supply to here, and then I've got to run 4 wires out of here to the stepper motor, but they're going to go through these plugs I showed you yesterday, and I'll be using these 5-pin plug and socket, and that's the socket and the plug, and I've got to make a panel on the side, so they'll all run up to the plugs, and again they'll all be the same colour wires just for simplicity. And just a bit of a note about the wiring, this is actually 6-core trailer light wiring. I've just stripped the insulation off the outside, used the 4 wires. It's probably a bit cheaper than trying to buy rolls of different colour wire. I just went this way, and the wire is suitable for the current that it's got to carry. So okay, the next thing now will be to wire in the plugs for the external cables going to the stepper motors, and I've also got to wire in these homing switches, and the emergency stop button that's actually going to be hardwired. It's used as a normally open contact, so I need to hardwire it, no plugs, no socket arrangement, just directly straight into here. Well, I've wired the DC power from the power supplies to each of the 4 stepper motor drivers and also to the CNC MyPlasm controller. Now what I'm doing now is I'm just on the back side here, this is lying on its side, so maybe I can do this better. This panel here, I've just fitted this panel into the side of the PC cabinet, and I showed you before I'm going to use these 5-pin plugs and sockets. Now they've got to go in this panel here, so I've got the room between here and down to this line here. So these are 15.5mm diameter, so I can drill a series of 16mm holes, and I'll probably put all the stepper motors across the top, and then I'll put the homing switches and the proximity switches for the over travel on the neck. So that'll be the next thing to do. And then I can, with these fitted, then I can solder the wires from the back here and run them around inside to each of the output connection terminals on the 4 stepper motor drivers. So then I can wire all those in, and then that effectively will be the wiring done, and then we've got to do the same thing out in the field. Each of these plugs have, I'm either using 4 or 5 pin plugs. I've soldered fly leads to each of the 4 pins, and then I'll just heat shrink over the ends, check them with a meter to make sure that the continuity between the wire and the pin is okay and there's no shorting between the pins. And then, as you can see, the panel here, there's the panel that I'm putting all these plugs into, and once I've got the other 3 homing wires in, I'll then be able to wire up to each of the stepper motor drivers, and the homing switches go in these connectors, and this RS485 connector, which is the interface cable back to the plasma interface unit that tells the plasma cutter to come on and off, and also measure the arc voltage. That's got to go in here as well. And this is the plug with the heat shrink on. And just while we're here, I'll just show you this. I made a connections chart, so I just use this as an example, so I know that the connections on the various connectors on the MyPlasm CNC controller, just use this home Z as an example. It's got a plus, an in and a minus, plus a field screen. So I've made up a color code here, and that goes to the pins and then feeds out to the field, and I know exactly what wire is going to go where out in the field, as well as connected to the pin. So that's just a way of me keeping track of the colors of the wiring and where they all go. Well, the panel's wired up in terms of installing all the components. That's the MyPlasm CNC controller, the 2 power supplies for Y1 and Y2, X and Z stepper motors. The MyPlasm controller gets its own power supply. This is a little 24 to 12 volt step down regulator that I'm going to use for the fans. And mentioned before, we've got the X, Z, Y1, Y2 stepper motor drivers. And around the side here now, this panel's finished, and we've got connectors for the stepper motors in the field, X, Z, Y1, Y2, and these are the 3 homing switches, and this is the connector that goes to the plasma interface unit that connects to the plasma cutter, and that's what turns it on and off, and also measures the arc voltage, so we can use the torch height controller. Alright, so the next thing to do, and these 2 cable glands here, I've got a emergency stop button which will be on the desk somewhere, and then this is just a roll of cable to run along the cable tray to the switch that's going to be on the frame of the plasma cutter. I'm not exactly sure I'm going to put it yet. So alright, so now we're ready to go in terms of running the cables now from these out to the field, and that's the next thing to do. Now that I've finished assembling the panel and wiring all these plugs in, these are the motor cables and the proximity switch cables that go to the field. And as I mentioned before, we've got these sockets on the end, so these attach into here. See, trying to do it one-handed. Now I just want to talk about cable for a minute. Now all these cables going to the field is this style of cable. Okay, so what the cable consists of is it consists of a pair of a black and a white with what's got 1 written on it, and then this is another pair, this has got 2 written on it. It's also got a wire shield, and it's also got some alfoil wrapping as well. So this is shielded cable, and the idea of shielded cable is you only connect at one end, and I've connected it at the electrical cabinet end, and I showed you that little buzz bar. So all the screens, all the shield wires from each of the cables coming in from the field go to that, and then there's a common earth lead goes around to the mains earth. So any electrical interference that happens on these cables, should there be interference from the plasma cutter, electrical interference will be taken to ground or to earth. So that's the reason for using shielded cable. I'll just show you my cable management, and the cables, now this box is sitting on the desk at the moment, but it will be replaced with a new one, and it will be fitted down here on this frame. So at the moment these cables, I made an aluminium cable tray, which is just two pieces of angle welded together, and in it I've run this drag chain. This is the best thing since sliced bread. So all your cables clip inside it, and as the carriage moves up and down, it drags these cables in a neat and tidy arrangement, and I've done the same along the x-axis, and you can see that cable tray goes up. Sorry, this cable tray here, the drag chain has the cables in it, and it manages all the cables and keeps them nice and tight. And what I've done here is I've put a junction box on the end, so the cable comes in, terminates with these bootlace ferrules, and they're the stepper motor wires, and then it's got a lid on the top. Now the other thing I've installed too are these homing switches. Now this homing switch is on the Z axis and on this plate which we use to draw some pictures, and I'll show you that shortly. There's a little tang on there. Now this whole X assembly has a homing switch here, and it senses this carriage coming up to it. And on the Y, because there's two Y motors, the software needs to see two homing switches. These are the proximity switches, one on this side, and if I come over here, there's another one on here. This is a new addition, so the cable is only temporary, but it will be made permanent. And what I want to do now is I just want to show you how the machine homes and how you set up the soft limit so it knows how far it can travel away from the home points. Now setting up the software, it requires the configuration tab, and what you'd need to do is once you've wired everything in, you need to configure your plasma interface. Now this has a plasma interface, so it's ticked enabled. The voltage divider is set to 20:1. What that means is the arc voltage measured between the torch and the ground terminal internally in the plasma cutter has a voltage divider of it's like a step down. So if it's 20:1 raw voltage, if it's 20 volts raw voltage, it's actually 1 volt coming out. So it's a safer value coming outside the machine. Down here, the stepper, the micro stepping motor drivers. Now these are 400 micro steps per revolution, and that's configured by the software. If I go into the machine tab, by telling it down here how many millimeters of travel per motor revolution. Now these ball screws are traveling at 5 millimeters per revolution, so that's, once we've set those numbers for the X, Y and the Z, the software decided 400 micro steps was required, and I'll show you in a minute how to set that up on the card. Axis soft limit values is, I know that I can, from the homing point, my X can travel 1300 millimeters across, my Y can travel 1300 millimeters backwards from the front left hand corner, and my Z axis has a maximum limit travel of 100 millimeters. Now over here we've got homing switches, and we've activated them by ticking the box, and these values up here are to do with hand speeds and how fast it will travel when you're actually moving it by hand. And the homing, I'm going to just change this because this is a bit slow, so I'm going to make that 1000. So 1000 millimeters a minute of travel for the X and Y, and I'll make 500 over here for the Z because it doesn't travel very far. Okay, the functions tab, that's pretty much not needed at the moment. Okay, let's get out of here, and what I want to do now is if I push this homing button, this reference XYZ, that will actually home the machine. So I'll show you where it is now. So it's just sitting here. The Z hasn't reached its full travel. Sorry, the Z is sitting here, the X is away, and the carriage is not near. So the reference point is this front corner of the machine. This is home. So what I'll do is I'll hit that homing button, and you can see what it does. What it will do is it'll travel up to the homing switch, it'll sense it, then back off a bit, and then once it's done that, the X will come over, this little light will come on the proximity switch to say that it's seen it and back it off. Then the carriage will move forward. Now that we've gone through the process of homing the plasma table, this front left corner is the reference for home. So everything that happens is from this point. So the carriage can move across 1300 millimeters. The y-axis can move down the rails to a maximum of 1300 millimeters before the soft limit says stop moving. And the same here with the z-axis. It's at the top of its limit now at 100. It can travel down 100 millimeters. And that is in relation to where the torch will be, and we're going to run some felt pen tests, so we'll use the felt pen as our reference onto the paper, and we'll show you that shortly. When you configure the system to run the stepper motors, these stepper motor drivers have a series of dip switches, and they're those blue switches there. Now, up is off and down is on, and they're numbered 1 to 8. So number 1 is on the left-hand side and number 8 is on the far right-hand side. Referring to the table on the side of this stepper motor driver, you look at your peak amps. Now these stepper motor drivers for X and both Y motors are running 4.2 amps. So the closest I've got is 4.3. So I need to put the dip switches. Switch 1 is on, switch 2 is off, switch 3 is on. And for switch 4, this has got off equals half, on equals full. What that means is when the motor is powered but not running, it's only got half current sitting on it, and that's just a saving thing. So we've opted for having that off. And switches 5, 6, 7 and 8 are to do with your microstepping of your motors. Now down here, you saw before the software said 400 pulses per rev, which is 400 microsteps. So I need to set the switches off, on for the dip switches. Now the Z's slightly different because the Z motor is only 3 amps. So I need to set that to on, off. And once they're configured, you're getting the correct amount of signal to the motor in terms of the current to drive it, and also the correct number of microsteps in order to get accuracy when you're driving the gantry around.
Now that the table's wired up and running, we've run some test drawings. I was going to say test cuts, but it's actually test cuts in inverted commas. Using the MyPlasm software, we just chose a few designs plus one of our own, and we just drew some basic shapes with it. And we had a camera on here, and this little bracket, which is actually where the torch will end up bolting, I made this little mounting bracket, and we put a felt pen in here, and we just ran some paper on a metal plate behind, and we just ran around and traced some shapes. So I'll just show you how that looked.
For these tests, we've just got a piece of 10mm steel plate here sitting up on some 100mm spacers, and that's just to elevate the workpiece to where it actually will be once the water table's in and all the slats are sitting in the water table. Then this is about the height that the job will be. So we've got this bracket here with a felt pen in it, and we've got a piece of A3 paper, and we'll just go over to the computer and we'll run the software, and you'll see the program has got a circle inside a square, and we'll just run that test and you'll actually see it draw on here. It's pretty cool watching it go around and sort of draw shapes on the paper. We're just going to draw this sign. This is another one, and this is 350 wide by 88.9 high. I'm just going to run this at 3,500 millimeters. Our cut height is 0, and the pen will be zeroed, so it'll know where it's going to start. Floating height of 10 mil, so it'll come up and run around. And we'll just position the torch. It's over there in the corner, and we're going to tell it to start from this point. Zeroed the pointer, and we're going to go again. That's better. So it'll run over, draw those circles, we'll draw those. As you can see here, the Z-axis is on 0 while it's drawing, and when it travels it goes up to 10, and when it comes back down to the paper it reads 0, does its little drawing, and then goes back up to 10 while it moves, because that was the value we set here at the floating height. Down here we have a working time, so we can see so far it's taken nearly a minute to do this shape. I'll just wander over here. Pen's a bit fat, I know. So it's trying to draw a thin line, and I've got a rather fat felt pen in there, but you get the idea. Ideally I'd use a thin marker pen, but it's the only felt pen I have at the moment. You can see how it works, see the principle of it. In time that'll have a torch on it, and the torch will be cutting the metal as opposed to drawing a pen line on paper. So there you have it, and it has a working time of 2 minutes and 7 seconds for that particular design, and I said it was 350 mil wide, 88 mil high, so yeah, probably make that sign a little bit bigger, but as a test drawing it worked really well.
Well, that's it for part 5 of the video series, How to Build a CNC Plasma Cutting Table. Hope you've enjoyed the progress that you've seen from part 1 all the way to now. And in the next video, we'll actually have the plasma cutter connected up with a torch mounted onto the Z-axis, and we'll actually be able to cut some metal and show you how that all works. So stick around for that one. If you like the video, a thumbs up would be appreciated. If you'd like to subscribe to the channel, it'd be great to have you along. Subscribe button's down here. And if you have any comments or questions about what you've seen so far in this video or in the other videos, please feel free to put them in the comments below. I'll certainly answer all your questions. Thanks again for watching. I hope you've enjoyed the series so far, and we look forward to seeing you in the next one.